Okay, I'm going to finish 3.7 out here on just a whiteboard screen. My math lab is down at the point right now, so we're just going to go with plan B. So on question number D here, it asks to write an equation. So again, what do you need to know? So I always check for my slope first, then I try to get B, and then I fill in the blanks to write my equation. So the nice thing on this one is there's just not a lot of math to do. Sometimes there's more, sometimes there's others or less. If you look, it looks like it's going down by 3 all the time. And this is going up by 1 all the time. So change in y over change in x, it looks like my slope is a -3. Now, to get b, sometimes there's work to do. But if you look this time, well, maybe if I can notice, I mean, you have b. That is the b. This is the starting amount because I'm at 0. So I can write my equation, -3x plus 5, and be done. Now, to make sure I'm right, it would be a good idea to sub in a few points. So if I sub in 3 times 3 is a -9 plus 5. Does that give me an output of -4? Yes. So this point works. And I could sub in 2. So I could put a 2 in here. -6 plus 5 is a -1, which is the correct output there. So you can check your answer to make sure it's right. If you don't like doing that, you can still do y2 minus y1 and get your slope that way. You have 4 points to choose from on this chart. So pick any 2 points. If you don't like doing the change in y and change of x, you don't need to. And if you always like subbing 3 out of 4 to get your equation, you can always do that as well. So on this one, you know, you could pick a point like 1, 2, 2, -1. You could do your y2 minus that and 2 minus that. You're still going to get what? -3 over 1. So you're still going to get a slope of a -3. And you could always sub in 3 out of 4. So you could sub in input and an output. So I'll just pick this one. My input is 1, my output is 2. I could sub in my slope, and I could get 2 equals a -3 plus b. And I could turn around and add 3 to both sides and get b equals 5. And then I can still write my equation that I just wrote. So I mean, again, there's more than one way to do this. Okay, go ahead and look at the next example, and we'll talk about that. Okay, we did talk about this in a previous video a little bit when we talked about slope. But on question A here, it says, write an equation of a line that goes through -3, 5, and they want it to be horizontal. All right, so if I go backwards 3 and up 5, so go back 3, up 5, and I want a horizontal line. And so remember when we talked about if you can ski on it, right, even if it's cross country, it has a slope of 0. But it has a slope, it exists, it's just 0. And back then I said, I always kind of remembered it's backwards. So this is your x-axis. So this line is going to have the equation y equals 5. And it's a special case because you have to think about what's constant here. The y value is constant. The x can vary. My x can go back and forth. So if I wanted to pick, like if I wanted to go over 1 and up 1, or sorry, over 1 and up 5, I could put a point. If I want to go over 3 and up 5, or over 4 and up 5. But the thing that's consistent is the fact that y has to be at 5. My x values can be whatever they want. And so that's why this formula has no x in it. All right, so horizontal lines, okay, are kind of backwards of the axis. So this is your x-axis. This is y stuck at some number. And then for B, if I want a vertical line, -3, 5. So again, I would go backwards 3, up 5, but this time it's vertical. All right, so this time think again about, this is the one where when we skied on it, right, you can't ski on that. So this one has undefined slope. So it doesn't even fit the y equals mx plus b format. This is going to be x equals a number, and x is stuck at a -3. So again, notice what can vary. The y can vary, and y can be anything. So in the formula, it doesn't matter. You don't need a y because y can be whatever it wants. But again, if you go back 3 and go up, or back 3 and back 3, or back 3 and down, back 3 and down, that the fact is that the x is stuck at -3. And again, I always remember it's backwards of the axis. So this is my y-axis. So when you have a vertical line, it's x equal to a number because it's the x that can actually vary there. All right, let's see. Go ahead and try number 4 quick, and then we'll do that and maybe one other example, and then we'll stop. Okay, so number 4, we have 5, 8, and so I could graph this. If I go over 5, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So if I go over 5 and up 8, I'm right here. And so they want to know a vertical and horizontal line. So if I go horizontal first, let's see, this is my x-axis, so this is going to be y equal to a number, and y is stuck at 8. And notice the x's can vary, which is why it goes horizontally, but the y is stuck. So that's going to be my horizontal, right? And then if I go over 5 and up 8, and I go vertically, okay, again, my y-axis is my vertical axis, okay? So this is backwards, so I'm going to x equals, and x is stuck at 5. And again, let's think about what's happening. My x is stuck at 5, but my y can be anything they want, so I don't need a y in my formula, and that makes a vertical line. Okay, I am going to give you a problem to try. We're not going to do number 5, so I'm going to give you another one to try, or a couple of them to try, and then we'll end with that. So let me erase this, and then we'll start with some new problems. Okay, so go ahead and try both of these problems. Try to find the linear equation that fits this data, and then I will come back in just a little bit. Okay, so let's look at the first one. Again, I like to get my slope, and I usually like to use the input-output, but again, if you love the formula, go for it. This is going down by 2. This is going, what is that going? Down by 2 as well. Is that correct? Went down by 2. Did I write these right? Yep, and went down by 2. So -2 divided by -2 means the slope is a +1. And if you get ugly numbers here, I mean, fractions are fine. Just use a calculator. It's not a big deal. So I get 1. So I like to sub in 3 out of 4. So mx+b. Input, output, and my slope. So I'm going to, it doesn't matter. I'll pick this one. And I'll just switch colors here. So this is my input. Well, maybe switch colors for me. This is my input, and this is my output. All right, so my input of a -3, and I have an output of 4, and my slope is what, 1? So 4 equals -3 plus b. To get rid of a -3, add 3 to both sides. So it looks like b is going to be 7. So I'm going to write my equation, and then I'm going to see if it works. So my slope by that, and then plus 7. All right, and let's plug both points in. So if I sub in -3, I do get 4, which is good. How about -5? -5 plus 7 is 2. So I'm 100% sure I'm right because it's linear. It works on both equations. I know that I'm good. All right, let's look at the next one here. Usually I try to get m first, and some of you might be like, well, I can't get m first. You technically could if you write these as ordered pairs. So you have 5, -6. B is your y-intercept, so that's really 0, -3. And you could get the slope that way if you want. Okay, so this is going, what, up by 3 over here. This went down by 5, so what is that, -3/5? You could get it that way. The other way you could do that is actually sub in 3 out of 4, because you could be like, well, I can't find m, especially if you don't realize this is an ordered pair. But then you could jump to step number 2, which is sub in 3 out of 4. But the only difference is this time you're subbing in an input, an output, and b. You don't know m actually this time. So let's just try that method, see how that goes. So I have output, let's see, my input was what, 5, I don't know x. But this time it's kind of weird because I do know b. And if you don't like the order that's written in, you can rewrite it so it looks a little more algebraic. All right, so then I have to solve this then, and to get rid of a -3, I would add 3. So then I would get what, -3 equals 5x, and then divide both sides by 5. And notice I still get the same slope. So Either way, you can get the slope. It might look different, but again, remember, they might look different, but they're really, really not. They're all, you know, you need to find M, you need to find B. You just need to think about how you can do that. And then to write my equation, then I just fill in the blanks. And then I have my formula. And again, I can check this one point that I have. -3, that works. That gives me that output. All right, we're gonna pause here, and then we're gonna do a real life example, and then we will end. Okay, let's look at this real life example and try to kind of figure out how this plays out in real life. So, say if a person sells 3 cars, they make $3,500, and they sell 6 cars, and they make $5,000, and we want to write a linear equation for this. Now, some of you might be like, well, they didn't scale it up, because if you double the cars, right? If you scale this up by 2, then shouldn't you make twice the money? And if they were only paid by commission per car, that would be true. But a lot of times people have a base salary in addition to how much money they get in commission, and so they don't double that base salary. If you sell twice as many cars, you do not get double the base salary. Only the commission would double, but not the base salary. And so this is something where there's a starting amount for both. You know, there's some starting amount, and then there's a rate that goes with it. And so that is not proportional. Proportional things have to always start at 0, 0, so that if you have none, you double it, triple it, whatever, you still have none. So this is linear, but it's not, you can't just scale it up because there's a commission in there. All right, so let's look at this. Again, I'm going to make an input-output. If you would rather write 2 ordered pairs, totally fine. So I have 3 $3,500 and 6 $5,000. So notice that their money that they made went up by what? Is that $1,500? And that went up when they sold what? 3 more cars? So change in Y over change in X. So it looks like if I divide these, that the rate, because remember your slope is rate, is $500 per car. So it seems that they make $500 per every car that they sell. All right, so now I have to figure out B. And I'm going to erase this to create some space here. I think we have our data in the chart, so I'm going to leave it there. So there's a couple ways I can get B. One is to do the chart backwards. The other one is to do 3 out of 4. So I'm going to do this first, and hopefully if we have time we can do both. All right, so I'm going to sub in an input, an output, and my slope. So I'm just going to pick this one. So I have an input of 3, gives me an output of 3,500, and I have 500 here. So for those 3 cars, $1,500 of that is commission. To get rid of adding, you would subtract. So it looks like B is $2,000. So I now know the equation. I know the rate. They make $500 per car. And if you want to use C for every car that they sell, or X, doesn't matter. And I know their starting amount is $2,000. So this person, if they sell 0 cars, right? So they don't sell any cars that month, I could sub in 0 and they're still going to make $2,000. If they sell 1 car, shove 1 in there, sub it in, what is that? They're going to make $2,500, and then I could keep going. All right, the other way you could do this is to do the chart backwards because we know the slope, so I'm just going to erase this to get B. So if I want to take my chart and have it go backwards, so here's 3, I'm just going to go back 2, 1, and I have to get back to 0. So my slope is what, 500. So if I go back 1 jump, they'd make $3,000. Go back again, they make $2,500. Go back again, they make $2,000. And so I can get my starting amount for my formula that way as well. And then again, the nice thing about having a formula is then you can use it. You could say like, oh, when, say this person wants to make $10,000, how many cars do they have to sell? Or if they sell 20 cars, how much money are they going to make? So by knowing this formula, I can predict kind of future salaries and so forth. Okay. All right, we're going to stop there, and this is part 2, and we'll keep plugging along. Keep working hard.